Hello everybody, my name is Brian Jackson from Water Technology, and together with Paul Rasmussen, the team leader for flood preparedness from Melbourne Water, we're presenting to you the operational flood water control room currently in development for Melbourne Water. Melbourne Water have a vision for reliable services today while being ready for tomorrow. And to meet this vision, there are 8 key enablers that have been identified. The water control room project that we'll be talking about will support several of these enablers, especially the operating model, data, technology, analytics, as well as collaboration. So why the need for a water control room? Well, Melbourne Water have already spent $120 million since 2008 on various flood mitigation infrastructure solutions. However, in some areas, infrastructure solutions are not able to resolve the flooding. In these cases, other non-structural solutions are required, such as public awareness, education, and alerting, for example. In support of this, Melbourne Water already have an extensive array of data monitoring equipment and data management systems at their disposal. However, this is where the first issue arrives, in that these data management systems and data sources are sitting at various locations internally and externally to the Melbourne Water network. This includes the Flood Information Decision Support System you see here, the HISRA system, various data SCADA systems, web camera feeds, IoT systems in the cloud, the Bureau of Meteorology data that they need, and other sources. Beyond this, even though Melbourne Water have an extensive rain gauge network, many of the storms are actually still missing these gauges. So Melbourne Water are thus seeking to resolve both these issues. First, to improve their understanding of the inundation, timing, duration and intensity of rainfall events across the city that lead to flooding, as well as to advance their technology around using this data and turning it into information for the various individuals and divisions within Melbourne Water to make better decisions in collaboration with partners for their various needs. So to try and resolve these issues, Melbourne Water have chosen to implement the HydroNet water control room for a trial period of 1 year. This water control room is a cloud-based subscription service using the digital Delta approach. This means that the various disparate data sources are connected through live real-time connections to the HydroNet server, on top of which a number of services are running in real time. These then provide the user with dashboards and information that they can use to make decisions through the HydroNet portal, which works through the web browser, which is then making dashboards available anywhere in the world, and the user can then make the best decisions on the water challenges that they face. This has many perceived benefits for Melbourne Water, maximizing digital as well as bridging the interface gaps between these various data sources, and enabling simpler and easier data sharing with their internal and external stakeholders, especially with the desire to share this information with councils through council dashboards to be created. This improves transparency. They also see improved benefits in live data and live alerting based on that, and this all results in better community resilience and awareness and safety. There is also the potential in this project to connect to the Emergency Victoria app to improve flood information in that application. Before showing you what the water control room looks like and how it functions, just a quick overview of the implementation process to get there. The process kicked off with a functional design where the dashboards and data sources required were designed. This then started off with the data connections that were actually made to those various data sources, followed up by the configuration of the existing HydroNet functionality such as the map tool, chart tool, dashboard configurator, identity configurator, export tool, embed tool, and the HydroNet API. Once this functionality was configured, the subscription of HydroNet commenced to support and maintain the HydroNet software service. During this time, we are now in the process of developing further HydroNet functionality such as a rainfall exceedance tool, the hydro alerting tool, and the rainfall event selector and flood intelligence tools. So, when first using the water control room, you have to create layers and dashboards. These can either be created for you by a super user, for example, or an individual can create themselves through simple click, drag and drop mechanisms without any scripting or IT knowledge required. If you do this, you click on your connected data, which gives you a list of all of the various data sources that are connected to the water control room. You then set up a layer from those data sources, choosing the variable from that data source you would like, the time you would like to see it, the locations, which can be all of them or a subset of them, These are a list of all of them. You can then choose to aggregate a raster data source or pixel data source to various catchments that you have to provide catchment aggregated information derived from that raster data source. This is very useful for flooding outcomes when you need to know the rainfall that occurred across an entire catchment, not just on a pixel. You then create a legend and your layer is done. You can then choose which layers that you have created to go into which maps. And then you create your dashboards. The remainder of this presentation is to go through some of the dashboards that have now been created in the water control room for the Melbourne water staff to help improve their decision making. This first one is the rainfall dashboard. This shows the radar rainfall from the Bureau of Meteorology as well as the HydroNet gauge adjusted radar rainfall product against the Melbourne water rain gauges and the Bureau of Meteorology synoptic rain gauges. So you can see data from various different sources in one map. On the right hand side is the same data except it's been aggregated to the major catchments of Melbourne water. This is particularly useful for flooding as this aggregated information is used to generate alerts for flooding at important locations. If you click on any of these locations, you can then get a list of the rain gauge and the radar data or the catchment radar data that's available, and you can then choose to show that as a chart. You can then save that chart for use in other dashboards. Here is an example of such a chart that was created with two data sources. On the left of the dotted red line is the observed rainfall at the Elster Creek rain gauge, and on the right hand side is the Bureau of Meteorology's ADFD forecast for the coming days. So two data sources in one chart, now shown as a separate dashboard for the Elster Creek. This is another dashboard that's been set up showcasing the now awesome new nowcast high resolution short-term forecasts available from the Bureau of Meteorology. So on the left is the observed radar rainfall and rain gauge information up to now, and on the right hand side is the forecasted rainfall that's going to occur within the next hour or the next 15 minutes. This nowcast high resolution forecast information is fairly game changing and gives Melbourne Water much better idea of what is going to happen in the short term and enable them to start reacting to events before they actually recorded. Another dashboard created for the tidal information is just showcasing the observed tidal status right now and for the last 2 days across the Port Phillip Bay area against thresholds in the background. Another one is just showcasing the link to the Apollo image server, where you can see the Melbourne Water aerial photographs in the background, as well as a WMS server showing the center lines for the drainages against the HydroNet drainage river levels. This is the forecast dashboard showing the Bureau of Meteorology forecasts at various exceedances, the median, 10%, 25% and 50% exceedance, as well as a chart that has been created for the Yarra Valley on the bottom right hand side showing the current and forecasted rainfall at various exceedance levels. Finally, another example of the dashboards that could be created for councils once agreement is reached on these, and this is a dashboard that has been set up for the KC Council, in this case showcasing rainfall. The pixel rainfall on the left and the rain gauges, as well as the catchment aggregated rainfall at various levels going towards the right. Finally, I would also like to showcase the Hydro Alert functionality that has been set up for the Elster Creek test catchment. Here you can see the Elster Creek catchment showing in green, which means no alerts are currently in place. Setting up these alerts, you click on the catchment, you'll get a chart of the various alert levels that have been created against the observed rainfall, and you can see no rainfall. If you click on that, you can then get a spreadsheet indication of the various exceedance levels that were set up for different alerts, and the current status being green, no alerts. If an alert is actually triggered, then an email or an XML file is created and that is sent to various users, now including the Emergency Victoria app, with the XML information being sent to them to help improve the flooding information in the Victoria Emergency app, which is coming soon. It's still early days in the project, but the potential benefits are great. Users can spend less time focusing on collecting the data they need to make decisions and more time on actually making those decisions and collaborating with their partners to improve the management of the system. Thank you very much for your attention. If you have any questions, please do not hesitate to contact myself or Paul Rasmussen. Bye-bye.